Hi everybody! Today I want to show you how to create this nice abstract animation. It looks something like from dark TV series on Netflix, and if I remember correctly, in one episode there was this dark matter energy flowing, and I think this looks maybe a little bit like this, but it's just abstract forms, and we will create this. Okay. The Blender version, this animation which you could see, it was the rendered version. This is in Blender version, and it looks like this. Okay. So we will create this using geometry nodes. Geometry nodes looks like this, and I have to hide and to hide, and these are geometry nodes which will animate these icospheres. Okay. So we can begin to create this animation. So file, new, general, okay, don't save, and we can use this default cube. So we want to check this cube, okay, and we want to add some modifiers, geometry nodes, okay, new. And we want to expand this window to see our geometry node editor. So we want to check this node editor, okay, and to hide menu, and we can start creating our animation. We don't need our cube. We will use icosphere from geometry node. So I can unplug this with holding Alt key, okay, and now Shift A, icosphere. And we can plug this to geometry. Okay, I want to be subdivision 2 subdivisions. Okay, radius set to 1/3 is enough. Okay, and okay, let's expand this window to see better. Okay, and now what we want is extrude extrude mesh. So Shift A, extrude mesh. This is what we want. Okay, now later we will be using join geometry, and we can add this now. Shift A, join geometry. Okay, we will be using this later, but I can place it here now. Okay, so this box, individual, this checkbox, it tells you that you can extrude individual faces, or we can extrude it by whole area. Yes, and this is whole area, and individual looks like this. Okay, so let's leave this unchecked. And what we want now is to control this face, and to do this we will use math function compare. So Shift A, math, and change it to compare. Plug this to selection because we want specific faces to extrude. Okay, and now let's create a node called index. Shift A, index, and plug it to the first value. And this index plugged into the first value will give us index value indicating each element in the list. So now we can control by changing this value. As you can see, the faces selected is changing. We have access to these faces, and by changing this value we can control which extruded face is appearing. So what we want now is to add some animation, scene animation, to this value. Okay, so Shift A, scene animation, scene time. Okay, we will be using a math function called ping pong. Shift A, math, change to ping pong. Okay, as this name is telling us very much about what it will be doing. Yes, it will be something upside down and forward back. This is something like this. So plug this to this value. Okay, and seconds to first value. And one function we want is another function we want is math function multiply, because we want to speed up a little bit this animation. So Shift D to duplicate, place it here, okay, and change this to multiply, because we want to change a little bit of speed. So change this value to maybe 20, okay, and now if I will play this animation, look what it is happening. Okay, because the epsilon value, which will control the area of faces, is not changing. So let's stop this animation, and if I will change the amount of epsilon here, you can see that amount of this area is changing. So let's maybe give this 15. Okay, and you can see that the amount of area, extruded area, was changed. So now we are extruding more of faces. We can also change this value because we want to have more faces extruded. Maybe let's change it to 25. Okay, and let's see now how it will be doing. Okay, this is something. Okay, maybe it is good. So let's stop it. And another thing we want to control is offset. So this value, and we want to be pseudo-random. Okay, so Shift A, let's create a node random value. Okay, and plug this to the offset. And as you can see, some faces are extruded more and some less. And we want also to animate this extruding value. So let's add here some scene time. So create Shift A, scene time. Okay, here. Okay, and let's duplicate these two functions. Shift D. Okay, let's place it here a little bit, move it, and these three nodes will plug to this first slot. So plug it here. Okay, we can change, of course, the scale because we don't want so big extrusion of this. So let's change the scale to 0.2. Okay, and plug seconds to first value of multiply, and let's multiply only by maybe 0.6. We don't want to be as quick as this one. Let's see how it looks. Okay, it looks better. Maybe now we can duplicate these three nodes and plug this to the second value of our random value offset scale. Okay, and now we can control the maximum height of our extrusion, and let's set this to maybe 1. Okay, and maybe let's change the speed of this to maybe 0.8. Okay, and let's see how it looks. It looks much better now. Okay, and of course, as you will be changing these values, you can see that amount of or the area of extrusion will change. So of course we can add here also some pseudo-random numbers, but let's leave this at it as it was. You can later experiment with these settings. Okay, we have our base of this animation, and it looks pretty nice, but it's not it's just the start. So what we'll be creating now on this extruded face, on these extruded faces here, we want to create another icosphere that will be extruding their own faces. So what we will do, okay, let's clean this a little bit, and let's create a node called mesh to points. Mesh to points. Okay, and because we want to create instances on these extruded meshes, we want to plug this extrude mesh to mesh and change these vertices to faces. Okay, and let's create instance, Shift A, instance on points. Okay, and connect points to points. And now what we want to do is just to connect icosphere, another icosphere, to instance. So Shift A, icosphere, let's place it maybe here and connect it to the instance. But we want also to extrude the faces of this icosphere. So let's place another extrude mesh. So Shift A, extrude mesh. Okay, and maybe let's place it here. And now we want, of course, to join the new icosphere we created with extruded mesh into our join geometry. So we can connect instance on points to join geometry, and you can see it was attached. But of course we want to scale it down a little bit, maybe 0.5, and subdivision, let's change this to 2 subdivisions. And of course we don't want individual faces, and let's change for now a little bit scale to maybe 0.1. So okay, as you can see, it was done. And one thing that we want, another thing is we want this balls, new icospheres, only to appear on this extruded new extruded mesh from our base icosphere. So we can plug this compare function node to selection on points, instance on points. As you can see here, if I will scale it down, maybe 0.1, now the new created icospheres appears only on this extruded meshes from our base icosphere. And if I will play this animation now, okay, you can see that the new created icospheres appears only on this extruded mesh, and when the extrusion of each face is changing, they are also changing with this extrusion. Okay, let's stop it. And now we want to add, of course, extrusion of our new icospheres. So let's clean this a little bit here. Okay, you can add new point to this connection, shift and right mouse button and G to move, maybe here, G, and okay, to be more visually clear. So now we want, okay, maybe here also G, okay, and now we want to add to the selection also the compare function. So we can duplicate this, Shift D, duplicate, and connect to the selection. Okay, and now of course the same thing, Shift D to duplicate index, because we want to control like in this our base icosphere, we want to control faces in these new created spheres. So Shift here, okay, and now as you can see, offset is all. We can control the offset of the extrusion of these faces. Okay, and now let's duplicate these three nodes. Shift D. Okay, let's place it here and connect this to the second value. Okay, maybe let's clean this little. Okay, with Shift. Okay, because okay, maybe here, and now this Shift G. Okay, and maybe here G. Okay, and this maybe here. Okay, maybe also this. Let's move it a little bit. Okay. All right. Okay. So we have this plugged to this second value. And now, of course, let's see how it looks. How looks this animation? Let's play this. Okay, you can see that the base sphere is animated, the extrusion of the face is animated, and the new also icosphere created on the top of this extrusion is also animated, but the extrusion is not animated, so the offset of this extrusion is not animated. So we want to make it now. Okay, let's stop this. Maybe we want to change some things here with scale, maybe to change it to 14. Maybe this speed like to 10, slow it a little bit down. And okay, now what we can do is to change to animate offset. Okay, let's add a random value, Shift A, random value. Okay, let's move it a little bit to the top. Okay, let's plug this random value to the offset. Okay, and let's duplicate this and this, Shift D. Okay, connect set the first value seconds and the value, this value of ping pong to the first value. Okay, and let's change the scale of this to maybe 0.1. Okay, and second value, okay, maybe we want to duplicate this, Shift D, and connect to the second value, and let's change the scale of this to maybe, okay, let's leave it for now, and we want to change the radius of our icosphere to maybe 1 point. Okay, let's move this top to the first frame. Okay, let's see how it looks now. Let's see how the animation looks now. Okay, maybe we want to change some parameters here in compiler. Okay, let's change to 9, and maybe let's change this scale. No, let's leave this as it is. Okay, let's stop it. Let's change the radius maybe to this value. Okay, and let's see how epsilon will change the amount. Maybe this much is okay. You can experiment with these settings. Okay, and let's change maybe the second parameter of the extrusion value to maybe 0.2. Okay, let's see how it looks now. It's better maybe. Okay, one thing we can add in here between join geometry and group output, we can add here a subdivision surface to see how it will look more smoothly. So Shift A on subdivision surface. Let's put it here. Okay, let's change the level to 2, and let's see how it looks. Okay, maybe a little bit better. Okay, one thing, another thing we want to change to create more random animation is to change scale of these instances, of these icosphere instances. So we can add here Shift A, random value, another random value, of course, Shift A, and we want to connect this random value to scale. Okay, and you can see that now if we change these two parameters, we can control this scale of instances, but we want it to be also animated. So we can now add Shift A scene time. Okay, and maybe we'll use some ping pong function, math function. Okay, Shift A math, connect to the first value. Let's change it to ping pong and connect to first slot. Okay, let's see how it looks. It is a little bit better. Okay, but we can duplicate it to control this top value of our scale. So Shift D, and we can plug it to the second slot. Okay, and change it maybe to 1. Okay, maybe this we can decrease it a little bit, and let's see how it looks now. Okay, maybe we can change this, maybe it could be a little bit bigger. Okay, maybe something like this. Okay, Let's stop it. And of course, another thing we can randomize is rotation. So we can duplicate this random value, Shift D, connect it to the rotation, and of course this is the same procedure, so we can duplicate all this to rotation. Or maybe we want only some basic rotation, so we can add only scene time, Shift D, and maybe this ping pong function. Okay, and we can connect it to the first slot and this to the minimum, and maybe max we can create maybe, oh, let's duplicate this also, Shift D, okay, and attach it to the second slot, and maybe let's leave it as 4, maybe it's 3 point, maybe 4 point. Okay, let's see how it looks. Okay, this is look pretty nice, but we can control rotation of our base sphere also, so let's do it now. So let's go here to our first icosphere, and we can now add transform geometry, Shift A, transform geometry here, and we can of course randomize rotation of our base sphere. So we can duplicate scene time, of course, scene time, and just maybe some simple multiply to control speed. Let's add Shift A math seconds value and change it to multiply and plug it to the rotation. So let's see how it will look, how it will be looking now. You can see that when we animate now, the base icosphere is rotating, so it looks more, maybe more, a little bit more natural now. Okay, let's stop it. Basically, we want to add as much randomness as we can, and of course you can tweak this very much. You can place your own values here and just have fun with this extrusion animation. And okay, what now we can do is to add some material to our spheres. Let's do it. Okay, let's go to the material panel and create new, and we can change this color to very dark, to more, maybe let's just put it black color. Okay, and now we want, let's see if it was applied. Okay, let's see the render view. We now have to add node called set material. So Shift A, set material, and add this. If you want to add this only to this basic sphere, we can place it here and choose material 01. But if we want to apply to the whole geometry node, to the geometry, we can with Alt unplug it, untouch it, and place it of course on the output area here. And now the whole material is attached. We can of course make it more glasses, more metallic, so that can change this parameter. Okay, and roughness maybe a little bit down, maybe 0.2. Okay, and let's play this animation. Okay, it looks pretty nice. One thing we can add here, of course, is shading. So Shift A, set shade smooth, place it here, and it will be shaded nicely. So let's play this. Okay, it looks pretty nice. Okay, maybe we want to make this little spheres on the top of the extrusion maybe a little bigger. Okay, let's change this value to 0.07. Okay, and let's play this animation. Maybe it looks okay. And another thing we can add to maybe create more deformation of this animation. We can add in material, we can add, of course, something that is called displacement, of course. Okay, let's change this view to shader editor, and now we can see our created material, and we want to add some displacement. But one thing we have to do is to change in our render settings from feature set to experimental. Okay, and here in material panel in settings we have to change surface displacement to displacement and bump. Okay, and now we can create Shift A displacement. Okay, connect this to displacement, and we can add some noise textures. Shift A noise texture. Okay, and connect this to the height. Of course, we can change the scale because the scale is too much scale. So maybe let's change it to 2. Okay, and let's see how it looks. Maybe I'll change to the material view. Okay, and play animation. It looks pretty nice. We create some displacement for our spheres. You can tweak this noise texture as you like. Maybe we can add some distortion, maybe to 1, okay, or maybe 0.5. Okay, and let's see now how it looks. Okay, so this is our animation created. Looks like maybe like some dark matter flowing. So let's see the render view, and we can play this animation. It looks pretty nice. Of course, you can tweak this as you like. Okay, and I can show you what settings to the render properties I use. Max samples to the viewport I change to 12, and max samples in render I also change to 12. Okay, and here in output I will use some frame rate settings to maybe 30, and now you can change output, of course, to your path, and file format we can change to FFmpeg video, and encoding, or I will choose MPEG 4, and of course video codec the standard H264. And now you can with these settings you can render your animation by choosing from any render animation or Ctrl F12. Okay, So basically this is it. This is the whole animation. Have fun. Thank you for watching. Okay, let's change the material. Thank you for watching, and I hope you will join me in the next tutorial. Thank you and goodbye.